So Dr. Meng Xia is an assistant professor in the Department of Computer Science and Engineering at Texas A&M University. She obtained her PhD degree from Hong Kong University of Science and Technology and worked as a postdoc at Carnegie Mellon University and also Korea Advanced Institute of Science and Technology. Respectively, her research interests are mainly focused on human-AI interaction, data visualization, and educational technology. She published papers at top conferences, including ACM-CHI, IEEE PIS, and ACM-CSCW. She received the Best Paper Award from CHI 2022, an Honorable Mention Award from PIS 2022, and the Best Poster Award from PIS 2019. She serves as a program chair for Learning at Scale 2024, a youth editor for the Journal of Visual Informatics, and a program committee member for CHI, PIS, CSCW, EUI, LAK, and many more. More details can be found at her website. I will share on the chat. So if you are interested to look further what her works, please visit her website. Dr. Xia, feel free to start your conversation.
Sure. Thank you very much for the introduction. It's my great pleasure today to share my thoughts and work on human-AI collaboration for personalized education. So as you can see, the first page, actually, I used the Midjourney to generate the image. I'm wondering, if we have also used generative AI to generate images for your presentations, or use ChatGPT in coding or writing or preparing your education materials. I believe that many of us have used new generative AI in education or learning scenarios. Not only in our practice, but also researchers in computer science and education technology have also actively explored the new AI technologies to improve education. As an example, I have compiled the data on the number of 4 research papers that utilize AI or large language models in this year's AI in Education conference and the Learning at Scale conference. The figures are striking. At AI Ed, a substantial 76% of papers used AI, with 60% of that AI being large language model. Similarly, at Learning at Scale conference, 73% of papers used AI, and a significant 75% of that AI was large language model. So we can see AI has been actively used and applied and explored in the education domain. And all these AI technologies try to address the fundamental or foundation education challenge of personalization. So why do we need personalization, and why is that challenging? Many scientific studies have shown that personalized learning improves learning performance when the learning instruction and the materials are adapted to a learner's, for example, the non-cognitive aspects like motivation, and also cognitive skills, for example, knowledge and the problem-solving strategies. It is challenging because so many factors need to be taken into account, and how to infer this information is also non-trivial at all. So my vision for education is personalization at a scale. So traditionally, we have classroom education, even small-scale classroom education, so that the instructor can address different learners' needs. But nowadays, we know that we have big and large classrooms, and also we have online learners. With the development of the technology, luckily we have something called massive open online courses like 10 years ago. It brought a trend in scaling education by providing educational videos online. However, personalization is not well addressed. With the new generative AI techniques, it's very promising to achieve personalization at scale. So let's first see the AI roles in achieving personalization at scale. I summarize them into 4 phases: prediction at scale, authoring at scale, tutoring at scale, and grading at scale. We can see that AI is very promising and powerful in the different phases during education. However, AI is not perfect at this moment. For example, first, it may generate inaccurate content at the different stages. In addition, when learners use AI, they may not use AI properly. For example, they may directly copy the answer without thinking about the learning process. Second, the tutoring process simulated by generative AI usually lacks pedagogical guidance. It's not intelligent enough to know when to give examples, give answers, or even just wait for constructive struggle. It is hard for AI to understand different learners' cognitive skills and non-cognitive traits with limited conversations. Lastly, currently it's very easy and cheap to build a tutoring agent with large language model. However, it's very costly to evaluate and it involves a high risk in deploying it in reality. So to solve those issues, we need human-AI collaboration. AI is good at reckoning, but not judgment. Reckoning is about calculative predictions, and judgment is about practical wisdom. So it's humans that have the judgment. For example, educators or instructors like us are the people who can give pedagogical guidance, and the learners are the people who know more about themselves, their motivation. So we need something to support this human-AI collaboration. In particular, we need techniques that can help educators and learners to analyze those learning behaviors at scale and explain the AI techniques at scale and test those techniques at scale to complement AI for achieving personalization at scale. So first, analyzing at scale can help educators better understand the quality of AI-generated content and the interactions between learners and AI. To achieve that, let's see one of our latest work, still GPT-Vis, a visual analytics approach to understand the student ChatGPT interactions. So this work is published on IEEE Vis 2024, also the Journal of TVCG. So large language models seem to be an inevitable trend in education. One recent article mentioned that the importance of ChatGPT is something similar to calculators in education. However, there are concerns from instructors. How about the performance of these advanced AI tools? And also, use these advanced AI tools, can students still practice their higher order thinking? And how can we better design tasks and guide students to use these advanced AI tools? To address those concerns, we integrated ChatGPT into the curriculum of a postgraduate data visualization course for computer science majors in the first semester of 2024. In each in-class exercise session, we conducted the experiment during the last 40 minutes of the lecture. And it includes a 10 minutes self-learning segment with ChatGPT and a 25 task completion segment and a 5-minute conversation log upload phase. So yeah, we asked them to upload their conversation with ChatGPT to our system. In total, around 700 unique conversations with around 2,500 turns were collected after filtering the empty conversations and some unrelated things. And then, to analyze this data, we actually derive our design requirements based on the interviews with 2 data visualization course instructors. And we summarize that we need something to show the overview of students and the task data. And we would like to summarize the macro level conversation characteristics and identify micro level interaction patterns, tracing interaction pattern evolution, evaluate interaction pattern performance, and examine detailed raw data to understand the students' interaction with ChatGPT and guide the future design of the learning tasks. And we created a coding scheme to map realization tasks to reflect students' cognitive levels based on Bloom taxonomy. And we actually code their questions in terms of learning-related things and also ChatGPT-related, their prompt strategies. For details, you can refer to our paper. And then we developed this visual analytics system to satisfy those design requirements. The system has 3 views: the filter view, pattern view, and the detail view. The filter view, the instructor could quickly see the distribution of the task difficulty and the question type, the student scores, and also their background, whether they have visualization background, CS background, ChatGPT background, etc. And in the middle of the pattern view, we can see during the conversations what kind of strategies have been applied in communicating or interacting with ChatGPT. And we use a different color to show the different levels of Bloom's taxonomy. And here we have the detailed interaction pattern view. We can see for students who receive higher scores, what strategies have they used, how they interact with ChatGPT, and what information they can gain during the we can see here the detailed interaction patterns, the take turns behaviors between students and ChatGPT, and which strategy have been used. And on the right-hand side, we can see the detailed dialogue information and also the task students is solving. So based on the system, we ask instructors to try it and give us feedback. For example, here we can see, for students who receive relatively higher scores, they usually ask follow-up questions. Not only just ask for the definition about something, but also try to ask follow-up questions to get the to solve the tasks. And in the evaluation, we found that more than 90 students enjoyed using ChatGPT in their learning process. And there are strong positive correlation between the information gain metric and expert judgment of ChatGPT response quality. So currently in the system, we automatically use ChatGPT to calculate the information gain of each round the students get. And also based on the interviews with the instructors, they mentioned that the ability to discern students' overall cognitive level at a glance is highly appreciated. And there's some other positive feedback. So not only utilizing large model and data variation to analyze the students' interaction with ChatGPT, we're also analyzing other programming, collaborative programming behaviors in a programming course. And this work is on the review. I will not go into details. So second, explaining at scale can address the potential issues of lack of pedagogical guidance in the tutoring systems. And we always say, we will try to use algorithms, intelligent tutoring system to help students. But as usually it's researchers who design those systems, but not educators. How can we empower and involve educators in the process to better optimize the intelligent tutoring systems? And also for learners, we sometimes also need to explain how the feedback is generated and how they can communicate with the AI so that the system can better personalize for their own needs. So here is one example about explaining at scale for educators, involving teachers in the data-driven improvement of intelligent tutors. And this work was published on AI Ed. So we know that there's something called intelligent tutoring systems, and which give stepwise feedback to students, hints, and something else. And however, the initial design of such system is often not optimal, and it's not easy to imagine. And you need to foresee all the potential solutions of the students. So for example, here the question is to solve 4x plus 2 equals 6, and the student's input is 2x plus 1 equals 3. However, the hint provided by the system is still asking the student to remove the constant on both sides. Obviously, the student actually do the division first, but not just move the constant, but the system is not adaptive enough. Sometimes, it's not easy. This is an easy example, but sometimes it's not easy for instructor to foresee all the potential solutions. So we developed a research prototype to help teachers understand how the hints and feedback designed and given to different learners in the intelligent tutoring system, and also how different learners try to solve the problem. A quick example that we can see in the system, there are like 10 students ask hint in the first step, and after that, some students still have troubles in solving the problem. The red means, okay, they did something wrong. And the hint, we show the hint, you have constant on both sides. So in this way, the instructor can better understand how the hints and feedback are given and which group of students were given which kind of hint, so they can optimize the system. The explanation not always given using visualizations. Sometimes also in the recent work, we also use text to explain why ChatGPT, why large models give that certain kind of feedback in the context of personalized study plan generation. We not only use the language models to help students to generate their learning plan, but also explain why such plan is generated. Lastly, using human AI collaboration techniques in testing at scale can potentially address the issue of lack of evaluation of AI-driven techniques and the high risk of deploying it in reality. First, let me give an example of how large models can be used to build conversational tutoring system. So in this work, which published on AI at 2024, we know that the benefits of intelligent tutoring are that they are effective. Sometimes in some studies, they show they can be effective as human tutors, and also they can be scaled. The most of the benefit would be this scalability, right? It's automatic, it can be scaled to millions of learners and provide a formal framework for thinking about tutoring process. However, the limitations of the intelligent tutoring systems are high cost of content authoring. And also, just as I mentioned, you need to foresee the different ways students will solve the problem. And in this kind of conversational tutoring systems, the limitations are limited language understanding previously, and limited conversation facilities, and limited question answering facilities. But nowadays, with large models, we have it's promising to solve these problems. So in this work, we designed and developed a large language model drive system for learners to achieve learning by teaching. So this system, the learners can teach the student agent here. We have a student agent which can ask questions automatically, and the learner tries to teach the student agent by answering those questions and give guidance. And also, we provide an expert agent here for the learner if they cannot answer some questions, so that they can get feedback and help from the professor agent. But all the amazing thing here is that all the tutoring materials, all the dialogue logic, and all the questions are generated and supported by ChatGPT automatically. What we need to provide is just the lesson text. Here are some detailed example of how they talk to each other. And also we have some, we evaluate the feedback given by the student. If it's incorrect, or we give some feedback and ask the learner to fix it or reflect on it. And the next step of our work is to enable safe deployment of such systems. We're now working on how to, we know that it's we will have high risk if we directly deploy this kind of things in reality. So we try to see how we can simulate different learning scenarios and provide educators the feedback at scale using technique, visual analytics or some other techniques, so that they can confidently deploy the system in reality. In one of our recent work, we are working on using language models to simulate the students' behaviors in online tutoring, and also for novice tutors to train their tutoring skills, especially those part-time tutors, to train their skills to engage students with this kind of simulated learners. So I have introduced several examples to show how AI and human can complement each other in addressing personalized education. Actually, there are more works that I have done for your reference. So we see that analyzing at scale is not a new role for human AI collaboration in education. More importantly, we see the need to work more on explaining at scale and testing at scale. I hope to use visual analytics, AI, and other human AI interaction techniques and the research methods to upskill educators and the learners to better utilize data and AI for personalization at scale. That's all my work, and now I need the lab Dream Lab. The Dream Lab focuses on human AI interaction, data validation, and education technology, aiming for adaptive education with visual analytics and emerging techniques like NLP, AR, VR, augmented reality or virtual reality to help learners discover their dreams and unlock their potential. Welcome to know more about us, and welcome to collaborate with us. Thank you.
All right. Thank you so much, Dr. Xia, for your presentation. I am opening to the floor. If you have any questions, any kind of discussions, feel free to raise your hand or just turn on your microphone and ask Dr. Xia any questions. And meanwhile, we'll stop the recording as well.